Hello, we are discussing about GATE 2011 ECE paper. For the circuit shown, find the Norton equivalent current in amperes with respect to terminals P and Q. Norton equivalent current is related to the Norton's theorem, and Norton's theorem says that any linear bidirectional circuit which consisting of number of active and passive elements can be replaced by a single equivalent circuit consisting of equivalent current that is called as Norton current IN in parallel with equivalent resistance that is Rn. Calculation of Rn is similar to calculation of RTH. RTH is a Thevenin's resistance when you are using Thevenin's theorem. So now this is P and it is Q. What is the value of IN? This we are going to calculate. IN is also called as, this is generally called as Norton's equivalent current, and it is also called as short circuit current. Short circuit current flowing across terminals P and Q. Short circuit current flowing across P and Q terminals. That means to calculate this IN, first you have to short the terminals P and Q. That is, the terminals of interest must be shorted. So this is called as ISC, short circuit current, which is also called as Norton current. So after making this short circuit, how much current is flowing through these two terminals? That will be called as IN. That is what it is asked. Here it is not asked about the Rn, so we are not going to calculate Rn for this circuit. So now make a short circuit. This is what the short circuit I am making. So this is ISC, which is also called as IN. Whenever this is shorted, at that time this capacitor doesn't have any effect, because current is always go through this short circuit. Short circuit means zero resistance. Zero resistance means no opposition. So entire current, whatever the current coming through this J30 ohms, that flows into the short circuit, and it is flows into this 15 ohms, and it never goes into this capacitor. In other way also you can say, short circuit means impedance is equal to 0 ohms, and whereas the impedance of this capacitor is minus J50. Both are in parallel. Two impedances in parallel. So minus J50 in parallel with 0. The equivalent is 0 only. So 0 ohms is nothing but again short circuit. So this capacitor doesn't have any effect whenever these two terminals are get shorted. So now the circuit is going to be looks like, a current source in parallel with 25 ohms, and this 25 ohms is in parallel with this series combination, that is 15 plus J30, because same current is flowing through this both resistors, both impedances, J30 as well as 15. In these two impedances same current is flowing, that means they are in series. So I am writing this one as a Z, impedance Z, whose value is nothing but 15 plus J30, and current source is given as 16 amperes. So now we are going to calculate IN, that is current flowing through this Z. IN, Norton equivalent current or short circuit current. So ISC can be written as, using current division rule, 16 times of 25 divided by 15 plus J30 plus 25. So that means it is 16 into 25 divided by 40 plus J30. 40 plus J30, and 16 into 25 means 400 divided by 40 plus J30. So if you take 10 common from the denominator, then ISC is equal to 40 divided by 4 plus J3. So take rationalization. So that 4 minus J3 multiply and divide with 4 minus J3. So ISC is equal to 40 into 4 minus J3 divided by A plus JB into A minus JB. Formula is equal giving A square plus B square. A square is 4 square, that is 16, plus B square is 3 square 9. 16 plus 9 is 25. So 25 1 and 25 1.6. Okay. So 1.6 into 4, ISC is equal to 1.6 into 4 is 6.4 minus 1.6 into 3 is 4.8. So short circuit current is 6.4 minus J 4.8 amperes. So the right answer for this question is A. A is the right answer. Thank you.